Okay, so here we've got a stone is thrown vertically upwards, the speed of 14.7, so we'll take upwards as positive. Okay, acceleration then acts downwards, opposing it, so we know now that A is minus 9.8 because we've taken upwards as positive. U is 14.7, okay, and it says that this cliff or whatever it is 49 meters above the ground, so that's why I've written 49 there. So part A then says find the time taken for the stone to reach the ground. Okay, so for this stone to reach the ground, which is down here, it needs to have risen to its max height and then fallen down here. So this is where we're starting. So this is where S is equal to 0. Displacement is 0 here. As it goes upwards then, displacement becomes positive. But then, as it falls then and passes through our 0 displacement, it ends up being a negative displacement. So we've got to think of this as an axis system. Upwards is positive displacement. Downwards then is negative displacement. So I'm going to set S to be minus 49. The fact is then, if I set S to be minus 49, I'm assured then that that's the time I get out is when the stone is going to be beneath my starting point. Okay, I'm 49 meters beneath it, in fact. Okay, so we've got those conditions there, and we want T. So if I use S equals UT plus half AT squared. Okay, so chuck it all in. Well, S is minus 49. Okay, U is 14.7. And then you've got half A, which is minus 9.8 T squared. So minus 49 equals 14.7 T minus 4.9 T squared. Get it so that we've got it in terms of a quadratic, because you can see a quadratic here with a positive T squared. So if I take that over, we get 4.9 T squared minus 14.7 T minus 49. Okay, when you get everything to the left hand side, that's the way to do that, and then get it equal to 0 then. Now, this quadratic, okay, I believe I can solve this, okay, using two brackets. Okay, you could use the formula method, but when you've got numbers like this here, 14.7, 4.9, 49, right, they relate to one another really well. There's lots of ways you could see how we could change this now into a nice looking quadratic, but one approach, you could just times it by 10 to start with. Okay, the reason why I would do that is if I times through by 10, it gets rid of the decimal point. So I've got 49 there, T squared. Times that by 10, you get 147T. Times that by 10, you get 490. Okay, so that kind of gets rid of the decimal point. But then you might see 49, 147, well 49 goes into 147 3 times, and 49 goes into 490, so we could then divide by 49. Okay, so if I divide by 49, you get T squared there, you get 3T there, and you get 10 there, equals to 0. Okay, quicker way, you could have just divided by 4.9. If you divided by 4.9, you would have got to this straight away. Okay, so two brackets then, T in both, okay, 5 and 2, minus there and a plus, and then you've got T plus 2 equals 0, or T minus 5 equals 0, so you've got T equals minus 2, which is impossible, isn't it, for time, so T equals 5. So that one is discounted, so it'll take 5 seconds, okay, for it to reach the bottom. Part C then, calculate the speed when it hits the ground. So the speed, part B rather, the speed, well again, let's just put in the values we know. A is minus 9.8, U is 14.7, S is minus 49, so we want V, and so I'm going to use V squared equals U squared plus 2AS. Okay, so V squared will be 14.7 squared plus 2 times minus 9.8 times minus 49 for S. So I work that out on my calculator. Comes out to be that. So then V will be the square root of that then, and I get 34.3 meters per second when it hits the ground.